Hello and welcome back to the Data Unite channel. This is Seko and today we will discuss about Decision Trees Machine Learning model. If you like this kind of information and you like to learn more about machine learning, please make sure that you like this video and subscribe to the channel. Decision tree is a supervised machine learning algorithm that can be used for both classification and regression problems. It is a tree-like graph where sorting starts from the root node down to the leaf node until a target is achieved. This is done by recursive or repetitive partitioning, where each node is a test case for some attributes and each branch is a possible answer of the test case. The partitioning is performed by implementing one of the two methods, information gain and Gini index, which are measures that guide the building of the decision tree. On the picture on the right, we can see how this algorithm works. The root node is whether you are at least 40 or not. If so, then do you eat fast food? If yes, then you are unfit. If not, you are fit. And if you are more than 40 years old, then do you do exercise? If so, then you are fit. If not, then you are unfit. This is basically a binary classification problem that can be solved by branching the records feature by feature. The implementation of decision trees has advantages and disadvantages. So first, let's see the advantages. It is easy to understand and it handles continuous and categorical values. There is no need to do feature scaling, and it can handle missing values. Decision tree is also robust to outliers, and the training period is not that long. On the other hand, the disadvantages are it can overfit easily, and this can lead to wrong outcomes. High variance is often present due to the overfitting issues, so hyperparameter tuning is quite important and it's necessary. And this algorithm is not good for large datasets because the tree might grow very long and become very complex. One of the following methods in order to build its tree. The first one is information gain, which measures how much information an individual feature gives about some class. It is the main information to construct the decision tree. The attribute with the highest information gain is split first, meaning that the decision tree maximizes the information gain. Information gain uses something that is called entropy, which is the measure of uncertainty in a random variable, and it decides how the decision tree splits the data into subsets. The splitting is performed using the following two equations. So the equation for entropy is the sum of the probability of x multiplied by the logarithm of the probability of x. And so p of x is the function of examples records in a given class. And then information gain, which equals to the entropy of the parent minus the weighted average multiplied by the entropy of the children. On the other hand, a Gini index is a metric that decides how often a randomly chosen element would be incorrectly identified. This means that an attribute with a low Gini index will be given preference, and the formula is the following. 1 minus the sum of p of x squared, and the split using the Gini index is done in the following way. So first we calculate the Gini score, then the data is split using a list of rows having an index of an attribute and a split value of that specific attribute. After the right and the left dataset is found, we can get the split value by the Gini score from the first part. Now the split value will be will be the decider where the attribute will be placed. And the last step is evaluating all the splits where the best possible value is calculated by evaluating the cost of the split. So at the end, the best split is used as a node of the decision tree. So this is a little bit different from the information gain, but still we are using some calculation that is giving information to the that is giving precedence to the features that give the best Gini score or the best information gain. And there are two steps to follow while building the decision tree. First, creation of the terminal node, and then the recursive splitting. So terminal node creation is while creating the terminal node, the most important thing is to note whether we need to stop growing trees or proceed further into building the tree, for which we can use the following input. Maximum tree depth, so we are deciding when the tree reaches the maximum number of nodes to stop the execution of the creation of the tree, and minimum node records, which is deciding when the minimum number of nodes have been created to stop adding new terminal nodes. On the other hand, recursive splitting is once the node is created, we will create a child node recursively by splitting the data set, and calling the same function multiple times. What about the outcome of the algorithm? So our prediction. So the prediction is done after the tree has been built by our recursive function. The same prediction process is followed again and again with both left and right child nodes until the final node is reached. So this means that when we reach the final node, this will be our outcome using this algorithm. So this was all about the theoretical part regarding the decision trees algorithm. And in the next video, we will see how we can implement this algorithm on a real-world problem using Python. Thank you for watching this video until the end, and please leave a comment if you have any questions or if you have any requests that you would like to be covered in the next videos. Until the next time, bye bye!